this video, we will solve 8 2022 ME Set 1 question number 63. This question is from the topic fluid mechanics, and the question is a steady two-dimensional flow field is specified by the stream function psi is equal to kx cube y, where x and y are in meters and the constant k is 1 per meter square per second. The magnitude of acceleration at point 1 comma 1 is in meter per second square. So now let's see the concepts we need to know to solve this question. So we need to know how to extract the velocity field from a given stream function psi, and these two expressions give you the u and the v velocity component when psi is your stream function in x and y direction. So u is partial psi partial y and v is minus partial psi partial x. Also, we need to know the total acceleration of the flow, and here we have the two components. So this is the x component of acceleration, and this one is the y component of acceleration. These are two vectors, and this is given by the local acceleration or the temporal acceleration. So these two terms are the local acceleration terms, local, and these two are the advective acceleration terms. The advective acceleration. Now, knowing this, let's solve this question. So we have been given psi as a function of x and y to be kx cube y, and since k is simply 1, we can just substitute it here and say that psi is just x cube y. Now from here we can calculate u, which is from the last slide we can see u is nothing but partial psi partial y. So this will be partial psi partial y, and that is simply x cube. Similarly, v, which is minus partial psi partial x, will be equal to 3x square y. So now we have u and v. Let's calculate the x component of the acceleration, which will be equal to partial u partial t, the local acceleration, plus the advective acceleration. And here we can see that u is not a function of time. As the flow is steady, we can take this to 0 and then just say that this is equal to u, which is x cube, times partial u partial x, which is 3x square, plus v, which is 3x square y. Oh, there's a minus sign here, so minus 3x square y, plus partial u partial y, which will be equal to 0. So then this becomes 3x to the power 5, and we are supposed to calculate the magnitude of acceleration at 1 comma 1. So ax at 1 comma 1 will just be equal to, for substituting 1 for x, will be equal to 3, and this is in the x direction, so we can write this as 3 I cap meter per second square. Similarly, for ay, we can use this formula. So the local acceleration plus the advective acceleration, this again goes to 0, and we are left with u, which is equal to x cube dv dx, which will be equal to minus of 6xy plus v, which is again minus 3x square y, times dv dy, and dv dy is nothing but minus 3x square So again we can substitute 1 comma 1 for both the x and y coordinates. So this will be equal to minus 6 plus 9. So again this is equal to 3, and since this is in the y direction we can call it 3j cap meter per second square. So the total acceleration, so let's write this down here. The total acceleration A vector is just 3I cap plus 3j cap, and now we can calculate the magnitude of this vector. So this will just be equal to 3 square plus 3 square, or 2 root 3, which will be equal to 4.24, and that is the final answer to this problem, 4.24. So we solve this problem and the answer is the acceleration is 4.24 meter per second square. And in order to know more about this topic on stream function and the local and total acceleration, you can refer to this NPTEL course video, Introduction to Fluid Mechanics by Professor Suman Chakravarti of IIT Kharagpur.